Hello, everyone. Welcome back again. Let's start from this section 2.3. So, section 2.3, we're going to talk about more graphs for quantitative data. The first one we're going to discuss is this dot plot. The concept for dot plot is pretty straightforward, but it can also just show a visual graph that can let us know what the data looks like, or how's the data distributed. So this example is prices in dollars of 16 DVD players. So we have 16 values in this data set. And then for this dot plot, all we need to do is we want to have a numerical scale that includes that horizontal wise, and then that includes all possible numbers. So now we just need to check the data and then plot it. So if we have a, for example, we have 210, we're just gonna put a dot here, and then if we have a second one of the same value, we'll put another dot, just give a little space on top of it, so that you can kind of have an idea how the data is distributed. So the data looks like this. So after that, let's talk about the reason we put color right here is because this is really important, the stem and leaf plot. Or some textbook may call it stem and leaf diagrams. In the stem and leaf diagram or stem leaf plot, each observation is separated into two parts, namely a stem, considering all but the rightmost digit, and a leaf, which is the rightmost digit. That way we can clearly see how the data is distributed. So now let's look at an example. Days to maturity for 40 short-term investments. So 40, that means our sample size, or we have 40 values in this data set. And then based on the way we're gonna use to construct this stem and leaf plot, so we're gonna separate the data into stem and leaf. Leaf gonna be the rightmost digit, and stem just gonna be for this one the 10th level. So we have 30 something, 40 something, 50 something, up to 90 something. So we're just gonna put all the values there: 3, 4, 5, 6, 7, 8, and 9. And then now for the first one, it's a 0. For the first value, 70, it's a 0. So we put a 0 on the 70th level. And then for the next one, 64, so we put a 4 right here for the 60th level, so on and so forth. So how many numbers you have here? The leaf area, that means how many samples you have for your data set, or datums. And then after that, we're gonna just wanna keep it well organized. So for the leaves, always start with the small one, and then up to the largest one. So this is a complete stem leaf plot for this example. And now let's look at a practice problem. So we're gonna construct a stem and leaf plot, which is for cholesterol levels for 20 high-level patients. So we actually have the solutions right here. So for the first one, we use one line per stem, because the rightmost digit is going to be the leaf. And then so everything but the rightmost digits, we just have 4 different values. For this example, we have 19, 20, 21, and 22. So how to find those? we can just draw a line, separate the rightmost digit, and with all other numbers but the rightmost one. So now if you look at, we have 21, we have 20, we have 19, and then I think for one value we have 22 right here. So 22. So now we're just gonna do the same thing as the last example, and then we complete a stem leaf plot. So this is the stem, this is the leaf. But for this one, if you look at the shape of the data set, it's kind of too narrow. What if we want to just spread it out and then make the shape clearer? Then we're gonna just do a 2 lines per stem. So we can do 90, and then we can do 2 19s, we can do 2 20s, 2 21s, and 2 22s. So for the first line of 19, that includes digits from 0 to 4. And then for the second one is from 5 to 9. So 0, 1, 2, 3, 4. We have a total of 5 numbers. 5, 6, 7, 5, 6, 7, 8, 9. That's another 5 numbers. So a total of 10 values equally separated into 2 lines. So for 19, from 0 to 4, we don't have any satisfy that. So we're gonna just leave it blank. If nothing, just leave it blank. But you still have to include this level. Same thing for 22, because you want it to be fully stated for the stem. So this is the second example for stem leaf plot. Now let's look at something called distribution shapes. So the distribution of a data set is a table, graph, or formula that provides the values of the observations and then how often they occur. So in chapter 5, we're going to start to discuss this distribution. So basically, for now, a distribution is more like how the data looks like, or a shape of the data set. So if we look at this histogram, we can always put a smooth curve on top to describe the shape of the overall shape of the data set. And then, for example, if we have the curve or the shape like this, we have different definitions for those. So if we just have one peak, and we call it unimodal. So 2 peaks, bimodal, and then more than that, we call it multimodal. Then another way to look at it is whether the distribution is symmetric. This is very important because symmetric distributions can have a lot of good property. So examples for symmetric distribution are going to be bell shape. This is very, very important, bell shape. Later we'll know this is called a normal distribution. And the triangular and uniform, they're all symmetric distributions. And other than the symmetric, we're going to look at something called skewed distribution. So we have skewed to the right or skewed to the left. So if the majority of the data of the group lies towards very left. So if you look at this distribution, most of the data points there lies towards the left end, and then leaves some unusual large number. So these long tail means you can rarely see one large number there, and most of the data are kind of small located to the left. Then for this one, we call it right skewed. And then same thing, if you have some unusual small numbers in your data set and the shape is like this, we call it left skewed. So when we try to distinguish a distribution shape, most of the time we're going to say whether it is symmetric, right skewed, or left skewed. Now let's look at population distribution and 6 sample distributions for the household size. So this is the population one. And then if you look at samples that we randomly draw from this population, the first one, the second one, the third one, the fourth one, the fifth one, and then the last one, the sixth one. They're all similar to the population distribution. And then again, we can say that the inferential statistic makes sense because the distribution shape from the sample is very similar to the population one. And then if we want to use the sample information to describe the population information, it will make sense. Okay, so now we finished section 2.3, and then now let's look at the very last section. Graphs can be misleading. So if you look at this one, it seems that not all the lines are parallel with each other, but actually if you use a ruler to check, they're parallel with each other. So this is just a very, very brief example about graphs can be misleading. So let's now look at some statistical graph. So unemployment rate. So if you look at the plot A, you can see here you have a big drop. So you may say February, March, the unemployment rate just dropped a lot. However, this is not a full picture of the unemployment rate, which is just a truncated graph. Because if you look at the scale, just kind of like zoom in from 7 to 8. But if you look at the real one, when you kind of look at this graph from a 0 to 8, the real unemployment rate, you can see this drop is actually not a lot. So this is one type of misleading graph. And this is the correct one. And this is the misleading one. And another one is something called improper scaling. So some advertisement may say the number of homes this year will be double last year. But actually it's just a one-dimensional scale. But if you draw it in a two-dimensional scale thing, then it'll look like 4 times of the number of the homes will be built. So that's another type of misleading graph. So when we draw graphs in statistics, in the topic of statistics, we want to just avoid those problems. Okay, that's everything for chapter 2, and again, worksheet 2 will be posted. So this worksheet 2 will be posted. Don't forget to turn it in before the due date. Okay, thank you.